Jnanam paramam dhyayam. Knowledge is supreme.
Welcome to this course on advanced transition metal organometallic chemistry. We have been discussing C-heteroatom bond forming reactions using transition metal catalyst, and this discussion has been going on with respect to our earlier discussion on C-C bond forming reaction. The main advantages of the processes that we are looking at involves the catalytic formation of C-C and C-heteroatom bond using lead transition metal catalyst, more often palladium or nickel that we have discussed so far. And what we have also observed that this C-C or C-heteroatom bond formation have been carried out in a catalytic fashion under mild conditions with large substrate scope, and that is what makes this reaction so effective, popular, and make them useful in various domains of organic synthesis. In our discussion on C-heteroatom bond forming reaction, we had discussed about carbon nitrogen bond forming reaction in this arylation of amine that we had discussed in our previous class. Now, what we had noted over there that this carbon heteroatom bond forming reaction can be often achieved by two different methods. The first one obviously is the nucleophilic aromatic substitution reaction that require drastic conditions, or that of using addition reactions of unsaturated compounds like alkene and alkyne, which is very challenging in absence of any catalyst, as both the nucleophile and the alkene and the alkynes are all electron rich entities. So, in this perspective, this palladium mediated aromatic arene amination reaction discovered by Hartwig and Buchwald about 2 decades back assume significance. What was observed that in this amination of arene reaction that this carbon nitrogen bond formation is happening in the reductive elimination step. A careful look at the catalytic cycle also revealed that this carbon nitrogen bond forming step is the reductive elimination step, and that this amination of arene catalytic cycle proceeds in 4 elementary steps, the 2 of which are similar to that of C-C bond forming reaction that involves oxidative addition and reductive elimination. However, the other 2 steps are markedly different than C-C bond forming reactions, and these 2 steps in amination of arene is amine coordination followed by amine deprotonation in using a base to give a palladium bidiimide species. We have also noted that if the amine has a alpha hydrogen, then a beta hydride elimination pathway kicks in, resulting in the formation of imine along with the production of a palladium aryl hydride species, which subsequently undergoes reductive elimination to give arene, and in turn regenerates the palladium 0 species, which also enters the catalytic cycle. So, having discussed that, we are going to look up at the scope and utility applicability of arenation of arene amination reaction in with more detail in today's lecture. So, one important example is in asymmetric aryl amination reaction. Examples: in asymmetric catalysis. And this is illustrated in this example containing phenyl bromide NHAC CO2 Me with palladium acetate as catalyst and palladium O toluene phosphine ligand in presence of cesium carbonate 100 degree centigrade in toluene gives the desired complex bicyclic complex containing a few 6-membered 5-membered rings in AC CO2 Me in 93% yield and 99% EE, and this one also is optically pure 99% EE. So, what it says that this is an extremely effective method that carries out intramolecular coupling. In an enantio selective fashion. So, another example in this front is involves intermolecular coupling, which we are going to be seeing right now. The previous one was an example of asymmetric intramolecular coupling, and this one is going to be an example of intermolecular coupling, and this is illustrated by Bromo substituted pyridine. The Bromo substitution can occur any part of the ring, it is so versatile, plus N H R dashed in presence of palladium OSE plus minus binap sodium butoxide -70 degree centigrade toluene does this amination very effectively, this intermolecular amination N R dash. So, this is a nice demonstration of versatile synthesis, of aminopyridines. These are aminopyridines. Occurs with ortho, meta, para bromopyridine. So, it can be anywhere ortho, meta, para, this amination would occur to give aminopyridine, and it occurs for primary as well as secondary, primary and secondary aryl and alkylamines. So, this is indeed a very versatile reaction which can couple bromopyridine with the bromine substitution being anywhere in the ring with that of amines to give aminopyridine, and these amines can be primary, secondary, aryl, alkyl, any type. So, one can just gauge at the depth and the breadth and the scope of this beautiful chemistry that involves intermolecular coupling of amino pyridine bromide with amines to give aminopyridines. Now, this reaction can be successfully extended for preparation of special pyridine ligands, can be successfully extended for the preparation of special pyridine ligand as is shown over here. Br plus NH2 PDOAC in presence of PDOAC hold to D PPP ligand sodium tiobutoxide toluene 70 degree centigrade to give this ligand NH pyridine in 87 percentile. Another important utility of this amination of arene is a transformation of phenol to aniline. Important transformation of phenol to aniline. This is a very utility driven transformation, and this is achieved by converting first phenol to tripletes, and then through a sequence of reaction it is converted to aniline, and this is beautifully illustrated by the example which is shown over here. R. So, this is substituted phenol first converted to triplets, OTF, and then in presence of amine pH, NH, pH, palladium acetate plus minus binap, cesium carbonate, toluene 80 degree centigrade, one would get the corresponding C-N coupled product, which in presence of H plus or H2 would give the desired aniline. So, this was also reported by Buchwald in 1997. So, this is a beautiful process in which phenols are converted to amines and substituted phenols are converted to amines, and in the first step the substituted phenols are converted to triplet, and then the triplet is subjected to this amination reaction using benzophenone imine with palladium acetate binap cesium carbonate toluene to give the corresponding C-N coupled product, which can finally hydrogenated to give the corresponding amines. Amination of arenes are used in preparing compounds in material science, applications exhibiting electronic and magnetic properties useful. So, in this regard, one important thing to mention is the polyanilines, and the polyanilines can be prepared by this arylation of amine in a much more selective fashion than it can be done with this oxidative coupling method. So, polyanilines synthesis in a regioselective fashion can be achieved by this arylation of amine reaction, as opposed to this coupling oxidative coupling pathways that would not be so selective. So, this is beautifully illustrated by the following coupling reaction, in which para-bromo phenol, para-dibromophenol plus arylamine with palladium acetate DPPF sodium tupet oxide toluene give this diamine NHAR. NHAR AR dashed equals phenyl, substituted phenyl group, as is shown over here. This, when coupled with palladium PO tol 3 whole 2 sodium OTBU benzene in presence of para-dibromobenzene Beer gives this desired compound NAR in air dashed N, and these are polymeric material, and the degree of polymerization can vary from n being greater than 10 and less than 20, and also by varying these bromide, aryl, and the aryl bromide and this arylamine fragment, as well as this dibromide fragment, one can create a large library of this polyaniline compound of different structure and properties. So, the beautiful chemistry is played out over here, where we see that there are two CN coupling happening, one in the first step where the bis substituted amines are made in the benzene ring, and subsequently that is coupled to another aryl dibromide using another palladium CN coupling. So, this is a wonderful example in which two CN couplings have been subsequently affected to give this polyaniline polymer, and in a very selective fashion. And also the degree of polymerization is quite large, because it goes beyond n equals 10 and something around n equals 20. So, with these we would just conclude our discussion on the utility of arylamination reaction, and what we had today spoken about is three important utility of arylamination reactions. What we had observed that during intramolecular arylamination, one can carry it out in terms of highly enantio selective fashion, where one could obtain E of about 98%. Then we had also seen that this arylamination can be effectively used to make aminopyridines, and these are very versatile form of synthesis, and it can carry out this synthesis with ortho meta para substituents along with primary or secondary aryl or alkyl amines. We had also seen that this arylamination reaction can be effectively used in preparing pyridyl based ligands, which are of great importance in this organometallic chemistry. We have also looked upon useful very important application in terms of conversion of phenols to anilines, and this also involves CN bond forming reaction. Specifically, what we had observed noted that substituted phenols are converted to tripletes, and then tripletes are then subjected to this elimination reaction with palladium to give the corresponding CN coupled product, and which can finally be reduced with the hydrogen to give these anilines. So, the real versatility of the Cl coupling is being played out here. What we have observed noted this palladium catalyzed arylation produces useful material for material science that exhibit interesting electronic and magnetic properties, and one such important thing is that of this polyaniline synthesis, which is achieved in a very regioselective fashion, starting from arylamine and dibromo benzenes. So, this reaction actually proceeds in two steps. The first is a CN coupling with a palladium catalyst to give the bis amine complexes of arenes, which are subsequently coupled with the bromo dibromo arenes to give the corresponding polyaniline product. The substituents and the fragments, this one as this one, may be so chosen that the desired para substituted products can be obtained. The degree of polymerization for this polyaniline Anilines are also quite large, as one can see that the value of n can be greater than 10 and less than 20. So, once again what all of these points to is the depth and the breadth of this arylation of amine reaction that we have been talking about in terms of formation of C-N bond and with regard to the utility space that is occupied in providing compounds of importance to materials chemistry and other sophisticated applications. So, indeed to summarize, this amination of arenes is a useful method, very powerful method that carry out this C-N bond forming reactions in a stereoselective fashion under mild condition, has a tremendous breadth and the scope of utility of this reaction, and also can be used for making compounds which has immense usage in materials science. We have also looked at the catalytic cycle, and we had seen that this is very much similar to that observed for other palladium mediated C-C bond forming reaction, except that the two elementary steps are different, and these are amination of coordination of the amines and deprotonation of the amines, and the other two elementary step, which is reductive elimination as well as oxidative addition, are however common for this arene amination reaction. So, with this we are going to come to an end with this arylation of amine reaction, and we are going to take up another interesting reactions, which is hydroaminations of olefins or alkynes in the subsequent lecture. These hydroamination reactions are also very useful in the sense that they are atom economic. So, there is atom economic. So, there is no side product or waste product produced as a course of the reaction. The other important challenges of hydroamination reaction is the fact that both the nucleophile and the unsaturated alkenes or alkynes are considered to be extremely electron rich. As a result, they are averse to mutually reacting to each other, and this is where the scope of organometallic catalysis comes in. The power of organometallic catalysis comes in making these two seemingly a difficult substrate to react and react in a meaningful way to produce something which is useful. So, with that I once again thank you for patiently listening to me in this lecture, and I look forward to taking up these new C-N bond forming hydroamination reactions in the next class. Till then, goodbye and thank you.